And we're here right now with, what's your name?
Neil Rana.
And what is your exhibit right now?
We from Vision Research, we manufacture high-speed camera over here in New Jersey, Wayne, New Jersey. What we have today, we have 710, which is shoot up to billion frames per second, million frames per second. Right now what we have, this is the setup. This right now, it's shotted with 1280 by 800 at 1500 frames per second. We got some kid coming in and we did just a small demo for them just to show the high speed, how that worked, the whole camera. What we have here, this is our small camera that could do 1200 frames per second at 800 by 600. This is like a base camera. This one could do million frames per second. That will be it.
You can touch the fog. They make fog machines. You could. It's a more expensive way. So this, what you're touching, oh sorry, that's just water. No need to be afraid. I just need some paper towels. This, what you're touching, is literally a cloud. Don't put your hand inside. No. Just the outside. Okay? This is fog. It's literally water that you're touching. Okay? But it's very, very tiny droplets of water. And that's exactly what a cloud or fog is. Tiny little water droplets.
What's the temperature? Is
Oh,
that
do
12
I?
now?
Is that why it's... Thank you. That's all I got. Thanks, guys.
What's the name of your exhibit?
This is the IEEE line following robot exhibit.
And what do you do? Like, what does it consist of?
So what this is a small robot right here that Rutgers IEEE has designed and made into a kit. And our members have built and programmed this, so it follows a line and teaches them the fundamentals of robotics. So right here we have the robot going around.
How does the robot know, like, exactly where the line is and how to follow it?
So on the robot is a little tiny computer called a microcontroller, which is attached to sensors on the bottom, which send out light and then measure how much light gets back. So when there's a black line underneath it, much less light is there, so it knows the line's there and turns to avoid it.
Okay, thank you.
You're welcome.
Can you tell us a bit about your exhibit and the name of it?
Absolutely. My name is Victor Lupi. I'm from Data Delay Devices, and we're a company that manufactures microchips. So what I have on display here are a couple of diagrams of how our products have evolved over the years. You see here, we've got, we've been around since the 1960s, so our products have evolved, have gotten smaller, have gotten cheaper, and have gotten faster. We start by designing and laying out the chip on a computer. We send that information to a manufacturer who fabricates the wafer. We receive the wafer, we send it to a packaging house, they cut up the wafer into little dice, and then the assembly house packages them into the final product that you see below. Once that's done, then we receive the parts and we have them programmed to our customers' specifications, and that's what you're seeing here. Once the parts are programmed, they're tested on our test benches, and what I can show you here is a signal passing into the line here, and here's the signal coming out of the line a prescribed amount of time later. And by switching these switches, I can determine how much I want to delay or time shift the signal that's coming into the line.
So these chips, they are used like in remotes and cell phones and certain things like that?
Yeah, they're used primarily in cell phone base stations. The cell phones themselves are actually too small to accommodate our parts.
Can you explain more about the planetarium?
Sure. It's part of the Mars Museum Outreach Program. So this is a program that we take on the road, we bring to schools, festivals, stuff like that. And inside, it's a real-time projection of the night sky. So it's exactly what you could see if we weren't by New York City and didn't have light pollution.
All right, sounds good. Do you think we could check it out, or is it open yet?
There's a show going on, but I can let you sneak in afterward.
Ooh, okay, sounds good. We'll be back for that.
Then, do you want 2 boosters or 3 boosters? Great. We want to go as high as possible, right? And we got to cap it. They're Alka-Seltzer. And then we got to stand back. Here we go. Woo! That was a high one. Yes.
Hi, we just watched a rocket launch, and we're here with Regina to explain us how it works.
Hi, how are you? My name is Regina DeLuca and I'm from Bayer Healthcare. We're doing the rocket launch, which we're having them design the rocket. We have a canister in the bottom. You put in a pipette of water. Then you put in 2 to 3 small pieces of Alka-Seltzer, cap it, put it up, and you're away.